Let's work on constructing and plotting confidence intervals in R. I'm going to begin by using the MT-Cars dataset. We can see that MT-Cars is a data frame with 32 rows, one row corresponding to each different car, and 11 variables. So 2 of those variables are miles per gallon and number of cylinders in the engine. Let's take a look at the relationship between those 2 variables. We can see that as the number of cylinders goes up, it looks like there's a trend for fuel efficiency to go down. I'm going to customize this plot a little bit. First, I'm going to add some jitter in the X direction. And then I want to change the actual points. So instead of open circles, I'm going to use closed circles. And I want the color of these closed circles to be dark gray. Now my goal here is to cycle through each one of these groups and figure out what the sample mean is, construct a confidence interval around that sample mean, and add that information to this graph. So the way I'm going to begin is by storing objects that are relevant to each one of these groups. So first of all, I need to have an idea of what my different groups are. So what are the unique values of SIL? Well, they're 6, 4, and 8. Now I've got this object stored, I can also figure out how many groups I have. So I've done that just by looking at the length of this object SILs, which has the unique values for cylinders. And I see that I have 3 groups. Now I can cycle through each one of these groups, calculate the means, calculate the confidence intervals, and add that information to the graph. Because that's a repetitive task, I'll use a for loop. And I'm going to outline the process within this for loop using comments. So the first thing I need to do is extract relevant data. And then I need to store the sample mean, construct the confidence interval, and store the confidence interval. So how do we extract the relevant data? Well, I is going to begin by setting itself to 1. That's going to be my first group. Which rows correspond to my first group? Well, that's going to be which MT-Cars SIL equals SILs I. So if I is initializing to 1, then my first group is going to be the first slot in this object SILs, or in other words, 6-cylinder engines. And this command will let me know which rows in the data frame correspond to 6-cylinder engines. Knowing which rows I'm working with, I can then extract the observations that I'm interested in. So here I'm going to be extracting those rows from this column miles per gallon, so that I have an object called observations that has all of those data. Having the observations, I can then calculate and store the sample means. But first I need to initialize some objects. So let's create those before we execute the for loop. I want these to be initialized to be vectors or matrices of NAs. So sample mean can be a vector of NAs that has length n groups. The confidence interval is not just one value. We have an upper and a lower bound on the confidence interval. So I'll create an object CIs, and this is actually going to be a matrix. I want to have 1 row for each group, and I want to have 2 columns, one for the upper bound, one for the lower bound. So let's store the sample mean. I'm going to be storing this in the ith slot, and this is just going to be the mean of my observations. In order to construct the confidence interval, I need to know the standard deviation of the observations and the sample size for the observations. So I'll create a temporary object called stdev. that is just going to be the standard deviation of observations. I'm also going to create another temporary variable called n, which is just the sample size or the length of my observations. Together with the standard deviation and the sample size, I can calculate the standard error of the mean. Now that I've got the standard error of the mean, I can actually construct my confidence intervals. So let's have the first column be the lower bound. So I'll be on the ith row, first column, and the lower bound for my confidence interval around this mean is just going to be the sample mean minus twice the standard error of the mean. I can copy that and change this to a plus sign in order to get the upper bound. And I'll have that in the second column. Let's execute this. Okay, and we'll take a look. So first, let's just print the sample means to see if those make sense. Alright, so we've got 19.7, 26.6, and 15.1. And that seems to match pretty well with what we see visually. How about the confidence intervals? Well, those look to be about what we would expect as well. Now our task is to add this data to this plot. So recall that we can add points with the points function. I'm going to add points for the means of each of these groups. So my x values are just going to be the actual values of the cylinders. I already have that object, so I can reuse it. And my y values are going to be the sample means. I'm going to make these a different color so that we can see them better. And I'm also going to make that point a little bit larger, so I'll use a CEX of 2. So there we have our sample means showing up. The next task is to add the confidence interval around those means. And I can use the segments function to do that. If you don't remember how to use the segments function, feel free to take a look at the help file. So the arguments here are going to be x0, which is the x starting point. That will just be cils. x1 is the x ending point. That will also be cils. y0 is the y starting point. And here I'm going to start at the lower bound. So I'll say ci's, all rows, first column. y1 is the ending point, and I'll say ci's, all rows, second column. For consistency, I'll use the same color, red, and make these lines a little bit thicker. So there we go. We've got our raw data in gray, sample means in red, and the confidence interval around those means also in red.